class. And now we're going to do the same thing, but we have one more wrinkle, one more thing that we have to learn how to do. Okay? Now is the time to stop using your mouth and start using your ears a little bit stronger, right? Strengthen how well you can use your ears. It's important to learn how to use both and know when to use both. Right? Different ones at different times, right? Okay, so here we go. If I have 10 grams of sodium carbonate, all right, how many, now this time I'm asking grams of that stuff do I need? Okay? So this is something new that you haven't done before, and so it might feel like, it's too hard for me. All right, but we have a solution for those feelings as well. What do we do with those feelings? That's right. First, what do we do to solve this problem? Put an equal sign, right? And then what do we do? Draw a line. Get out all those bad feelings so that you're not thinking about that, because now you only have to think about one thing, right? What's the one thing that you do next?
Unit to the right.
Units to the right of the equal sign, right? That's all you have to think about. You don't have to think about anything else. Please focus on using your ears so that everybody can hear right now instead of using your mouths, okay? Here you go, Jakey. You guys want to share that to write on? All right.
We also can write a line on the right side.
Now, do you guys remember, there's a periodic table. Do you guys remember from last class how many grams it was necessary to make a mole of sodium carbonate? It was 106. That's right, 106. Good job. So, how many grams do you think is going to be necessary to make a mole of the other stuff? Or I guess we don't need to answer that yet, right? What units go to the right of the equal sign? Looks like that's where we stop.
Grams
Very good. Grams of. Whoops. This needs to be fixed. Grams of. So grams of HC2H3O2.
Wait, how come it's not?
Because the question is, how many grams of? Right? And that's what we want here. How many grams are the things that says, how many of this, or what amount of that, or something like that, right? Okay? So that goes to the right of the equation. Now we have only one more thing, or one thing to think about. What's the next thing we think about?
On the left side.
Goes here. And what goes there?
The line.
We got the line, and then we put in what we have, which is 10 grams of Na2CO3. They've given us grams of Na2CO3, correct? They've told us that part, right? And they're asking for grams of the other stuff, right? Do we have to convert to moles and talk about it there? Or why can't we just use this to say, oh, what does this say? This says 2 of these and 1 of those. Why can't we just use 2 grams and 1 gram of that?
That's my sister. It's like, you know, the pound of that might be my sister. Oh, that might be mine. They're both great things.
Okay.
That one dirty.
All right. So this statement up here, can anybody translate this into English for me? For those who don't know chemistry ease, what does this say up here in English? Yeah. You can just say of those if you want.
2 of those plus 2 of those.
Oh, plus how many?
Plus 2.
Just 1, right? Just 1
Plus 1
of those.
of those.
1
Equals 1 of those plus 1 of those.
2 of them.
2 of those.
All right. You can also say 2 moles of this plus 1 mole of that, right? Moles are just, you know, a molecular unit. Yields 1 mole of that and 2 moles of that. Can I also say 2 grams of this plus 1 gram of that yields 1 gram of that and 2 grams of that? Can I say that too?
You can't say that unless they have the same weight.
Can't say that because the masses of these things are different from each other. Does that make sense? Very good. So we do have to go to that magical land of the what?
Moles.
That's right. We have to go to the land of the moles to get the power of the, to use the power of this equation. All right? So we need to get rid of grams of sodium carbonate and convert it to what? Moles of sodium carbonate. All right, so what units go down here? No, down here go grams. Grams of sodium carbonate, because that's what's up here, right? Grams of sodium carbonate. Na2CO3. What goes on top? Yeah, I'm going to make that a little bit small. Grams of sodium carbonate, Na2CO3. And up here goes moles of sodium carbonate. Now we need the numbers. How many grams are there in 1 mole?
106.
106. Does everybody remember how we knew that?
Yeah.
How did we know that?
We added up all the weights of the
That's right. We added up all the weights of all the atoms that were in there. I just threw it away, but I can get it back for us. Don't worry. Don't be concerned that it wasn't an important part of our lives anymore. It still can be an important part of life. I just filed it in the round file cabinet over there. Here it is. Remember this from yesterday?
Yeah.
Remember? This is how we added up what? The mass of Na2CO3, right? And we added up, found out there was 106 what? And what are the units on that? Grams for every mole of this stuff that you want. Yeah.
For this one, it says grams of Na2CO3.
Right.
How would that be different than 10 grams?
Well, 10 grams wouldn't weigh 106. 10 grams would weigh 106 times 10, right?
So 1,060.
So this is 106 grams for every mole.
Add a 0 though. Times 10, add a 0.
No, we don't have to times 10. We start with 10 grams, correct? And every 1 mole weighs that many grams. That's what we have to do there. Okay, now what units are we in if we were to stop right now?
Moles.
Moles of what? Moles of sodium carbonate. Okay? So we have to convert moles of sodium carbonate to moles of what? To grams at some point, but there's no conversion that way. We have to go from moles to moles, right? Because that's what the power of the equation would do. It tells us 2 moles of this for every 1 mole of that. So I'm in moles of sodium carbonate, and moles of sodium carbonate has to go down here. Why did I know that?
So it can cancel out.
So they can cancel out.
And then 2 on HC2.
All right, HC2H3O2, which is acetic acid. For every 2 moles of that, 1 mole of sodium carbonate gets consumed. Right? That's the power of the what? Of the equation. We went to the land of the moles to get the power of the equation, right? The power of the equation, the stoichiometry there. Do you have a pen? Does that make sense? Awesome. Okay.
Is this
Like
like
that a
a
5?
Dad,
That's a 2 and that's a 1.
Dad.
No, it's not like to the O.
Where?
Oh, it's just
Dad.
Is that like a real
A real equation system? It's real. Okay, so next. Next. What are we gotta go to next? We're already at the land of the moles, now we gotta get back to the grams. Back to grams. I'm in moles of what? Moles of HC2H3O2 right now. And I want to go to now what? That's right. So moles of HC2H3O2. And I need to go to grams of HC2H3O2. All right, do you guys know how many grams there are in every mole of that stuff?
No. Yes.
Can you figure it out?
Yes.
Let's see if you can figure it out. Is it 106?
No.
Why not?
And 1? That's a different molecule.
Different thing. Right, different thing. We need to know how many grams of this is equivalent to 1 mole of that. So in other words,
HCHO?
H
Why is H in there twice?
C2H3O2.
Why is H in there twice?
That's a good question. And the reason is because some chemicals, they write slightly differently to help us identify what kind of chemical it is. chemicals that are acids begin with an H. So they're trying to show us. They pull one of the H's over here to show us that that's an acid.
Oh,
But that's a different lesson for a different day, right?
So-
That's a good question.
you don't count the H as a hydrogen.
You can count every H. You can count everything.
I got
You got an answer? What did you get? 60?
60.
Anybody else get a different answer? Anybody get an answer? Did you add them up, Emma?
I have an answer, but it's 60.
Okay, so right now we want to focus our attention on identifying how many grams there are in 1 mole of that stuff, right? Can we do it on the back of this thing, or will it be too hard to see? I can do it right there, I think, right? HC2H3O2. Excuse me, friends. H
That means there's one H and two C's.
C2H3O2. How many carbons are there?
One. Two carbons.
I see 2 carbons. 2 carbons. How many hydrogens are there?
One.
4 hydrogens.
Oh,
How many oxygens are there?
2.
2 oxygens. All right. What does 2 carbons weigh?
Carbon. 2 carbons. 24.
Yeah, 12 each, right? 12 plus 12. That's 24 grams for every 2 carbons, right? 4 hydrogens. 4. 2 oxygens.
32.
16 plus 16. 16 and 16 are 32. All right. Did you guys know the song about the inchworm?
No.
Inchworm, measuring the marigold. 2 and 2 are 4. 4 and 4 are 8. 8 and 8 are 16. 16 and 16 are 32. All right, so that's how I remember that really easy, right? Okay, so 24 plus 4 plus 32.
60.
60? What you guys got, Emma?
60. It's a pen.
All right, so what is that? Why were we after that number? What does that 60 mean?
That's the gram.
That's how many grams per mole of this stuff. 60 grams for every 1 mole of that stuff. All right, so why don't you find out the answer now with your calculator? What do you call them? Calculators. Yes.
You know it's a calculator.
You have a calculator? Anybody have one?
I don't have one. Try out.
Find a partner that has one. Sister Scott has one over there.
1,200.
You have a calculator?
Dad, the answer is 1,200 divided by. Dad, we got a calculator right here. 3 times.
You're going to call somebody, huh?
See, I'm on the
I need somebody who has a calculator to get this answer for me. Who can do that? So here we go, Emma. Ready? 10.
Here's the answer, but really messed up. What? Dad got an answer.
Times 60.
Oh, we got it. 11.32075472.
11 point what?
11.3.
11.3. That's good. 11.
Yep, that's it.
11.3. What are the units? And divided by 106. That's the divided by. Divided by 106 times 2 times 60.
Divided by 106, divided by 1.
Okay. Very good. Now look. If I had a container, if I had my container here, right? Here's my container, and it has 11 point, how many? 3 grams of H2, or HC2, 3O2, this stuff right here in it, right? And then I take my balloon, right? How many grams of this stuff am I supposed to put in my balloon then? 10 grams, right? Because they see that?
If I have 10 grams.
Because they say if I have 10 grams of sodium carbonate, how many grams of this stuff? We decided it was 11.3. So if I have 11.3 of this stuff in here, I need to put 10 grams of that in there, right? And then I can put the balloon on top, and it will inflate, and I'll know that all of the reactants have what? Been used up, have been reacted, have reacted. Good job. Way to go. Okay? Does that make sense? Now, one more thing we need to understand before we can do the experiment, but we're out of time. So, next time we're going to talk about this. A lot of chemistry is done in water. And vinegar is not a vinegar. This is vinegar. This is acetic acid. Vinegar is only a solution of acetic acid, meaning that they put some into water. If you drank straight acetic acid, you'd die.
Wait, vinegar?
Not vinegar. Vinegar is acetic acid with lots of what? So you won't die.
Water.
Lots of water. So it's called a solution. Harry Potter calls those potions, right? Where you put something in and you add some other thing to make a liquid out of it, right? Yeah. So we'll talk about that next class. See you on Monday.